Our next topic is congruence. But before you continue watching this video, I would encourage you to look at the in-class activities called Introduction to Congruence. That'll get you an idea of the ideas that we're going to be talking about here, so the video will make a lot more sense to you. So I'll put a little pause in here while you do that, and then you can come back. Okay, so as I said before, we're going to be looking at the concept of congruence of integers. First of all, we're going to look at a model, and the model is going to be looking at congruence like days of the week. We're going to give then a formal definition of congruence, and of course we're going to look at some examples. So here's the model. I call it the days of the week model. If n is a natural number and a and b are any integers, we say that the statement A is congruent to B mod n means that A and B represent the same day of the week when a week has n days. So as an example, is it true that 7 is congruent to 25 mod 9? Well, we want to see if they're the same day of the week. Now, it looks like there are 18 days between 7 and 25, so you may think, oh no, that's not a whole number of weeks away from each other. Except remember, mod 9 means that we have 9 days in a week. So if there are 18 days between 7 and 25, that means that is 2 weeks. So 25 is exactly 2 weeks away from 7, and that means, yeah, 7 is congruent to mod 9 because 7 and 25 are 2 weeks away from one another. What about 12 and 19, mod 4? So here, the mod 4 means there are 4 days in a week. 12 and 19 are 7 days away from each other. And that's an awkward number of weeks because 4 days is 1 week, 8 days is 2 weeks, so 7 days is somewhere between 1 and 2 weeks. So it's not going to be a whole number of weeks. 12 and 19 are not going to represent the same day of the week. So no, 12 is not congruent to 19 mod 4. So let's go ahead and see if we can come up with a precise definition using the model, the days of the week model, as a guide. So let's say that A is congruent to B mod n. What exactly does that mean? Well, there are going to be some number of weeks between A and B, and that number of weeks is going to be a whole number. It's going to be some kind of integer. So let's say there are k weeks between A and B, and that k is going to be an integer. So if A is the bigger number, then to get from B to A, it's not true that A is equal to B. We're not done there. What's going to happen is if you want to get from B to A, then you take B and add those k weeks to it to get to A. So you take whatever number B is, add that k weeks. Now, the number of days in k weeks is k times n. Remember, the mod n says there are n days in a week. So if there are n days in a week and k weeks, kn is the number of days. So you take that B, add that kn number of days, which is k weeks, and that'll get you to A. Now, alternatively, if you wanted to, you could solve for B in that equation, and you would end up with B equals A plus negative k times n. That'll be significant a little bit later. So just realize all we're doing is solving for B and looking at that equation in a slightly different way. Now, if B is the bigger number, you're going to do the same thing, except you're going to flip the roles of A and B. To get from A to B, what you're going to do is you're going to start with B equals A. Well, maybe not equal A. A might be a little smaller. You're going to add however many weeks there are between A and B to A to get to B. So B is going to equal A plus those k weeks, which is, again, k times n days. And as before, if you solve for A in this equation, you get A equals B plus a negative k times n. And notice that in both cases, you can write A equals B plus some integer times n. Now, it's not the same integer in both cases. One's when A is bigger than B, and one is when B is bigger than A. In the first case, in that top item, that integer is just k, right? A is equal to B plus kn. In the second one, it's negative k, which, by the way, is also an integer. If k is an integer, negative k is also an integer. And we can also say that b is equal to a plus an integer times n. In that first case, that integer is negative k, and in the second case, the integer is k. So this is going to help us a great deal in defining precisely what it means for A to be congruent to B mod n. So here's the formal definition. So let A, B, and n be integers. And so the statement A is congruent to B mod n means any of these things, and they all are equivalent. They all look different, but they're all equivalent. So first of all, it means that A is equal to B plus nk for some k in the integers. And that k could be a positive number if A is bigger than B. It could be a negative number if A is smaller than B. Or it could be 0 if A and B are the same. B is equal to A plus nk for some k in the integers. Now the k in that second case is not the same as the k in the first case. They're both integers, but the second k is the opposite of what you get in the first k, as we saw above. Now this one may not look obvious at first, but an equivalent way of saying that is n divides evenly into A minus B. And if you can't see that, look at that first equation, A equals B plus nk. If we subtract B from both sides, we get A minus B is equal to nk, and that is exactly the definition of n dividing A minus B. And you can play the same game with that second equation, that B equals A plus nk. If you subtract A from both sides, you get n divides B minus A. Again, you take that second equation, subtract A, you get B minus A equals nk. And this last one, well, we didn't really think out this one, but you might have to think about this one. And if you get curious about it, you may force me to prove it in class. You can put it up as a question on the discussion board if you want. It turns out that if you divide A by n, and if you divide B by n, you get the same remainder in both cases. That one you have to think about. You may have to prove to yourself, see if you can do that. But that is also equivalent to all of those. Now, all 5 of these things are different ways of saying the same thing. A congruent to B mod n means each of these 5 things, whichever happens to be most convenient for you. All right, so now I want you to work on the activities. Well, finish the activities in Introduction to Congruence if you didn't finish those. But then also you're ready to go to the other activities, the ones that are called More Congruence. And those are on the PDF files included with this video.